Okay, so in this video what we're going to be doing is finishing off our last example of the lab. For this example what we're going to be doing is drawing a tetrahedron. And now for anyone that doesn't know, a tetrahedron is the same thing as saying basically a triangular based pyramid. So it's just basically a four-sided shape that is made up of four different triangles. Now, according to the question here, the plan of a base of a tetrahedron is shown. So this is going to be the base of our tetrahedron, so that bottom surface. So let's say the base of the pyramid itself. Edge AB rests on the horizontal plane. So AB here is resting on the horizontal plane. So that's touching, let's say, the XY line above here in elevation, because it's resting on the horizontal plane. Point C is not resting on the horizontal plane, so point C here. So that means our tetrahedron, so imagine this is the base of it here, is actually inclined upwards like so, where AB is still resting on the horizontal plane and C is being basically rotated up. Draw the complete plan and elevation. Okay, so to start this off, what I'm going to do is going to draw my base so it's lying flat on the horizontal plane. The reason I'm going to do that is because when I fold that down, then I can take an auxiliary view of it, draw my complete tetrahedron in the auxiliary, and then what I can do is rotate into position and then bring it back into my plan elevation and be able to find all the points in its rotated position. So to do that, I need to take my true length. So I know for all my triangles, it's going to have the same length for each one of the sides for the tetrahedron. And if I'm looking for that true length, all I have to look at is where I can see a true length here. Now I know my line from A to C is not, because remember, it's lifted up, so this line is distorted, so you can't see that as true length, nor can you see C to B. But what you can see is the line touching the horizontal plane, which is A to B. If I take that distance, which is this one here, and I mark it off above here, and then all I have to do is take a perpendicular line from this one through C, like so, and now that is our base of our tetrahedron lying on the horizontal plane. And now what I'm going to do is I'm going to complete, let's say, the tetrahedron in the plan here by just bisecting this angle here and bisecting this angle, and where they both intersect will be a point here, and that'll be the central point of my tetrahedron as it is sitting here in the horizontal plane unrotated. Now actually I only need to do one of these, because where it intersects this line here will be the same point as if I bisect this one as well as this one, it will be the same point. Like so. Spin my line through this point now, drop it back here like so, and this is basically my tetrahedron. You can see the base, which I'll call this C1, all the way is back to A to C, A to C to B, that's our base, and then we can see we have a side here, here, and here. Okay. Now what we're going to do is construct this above in our auxiliary view. To do that, I'm just going to construct one up along here, so I can look at see this line as a true length, and that will help me in the construction of the tetrahedron. Bring that up. X1, Y1. Carry my points up. Now remember, I know AB is going to be sitting here, so I don't need to extend that. Bring that back, mark that off as A/B, put this in as C. Now what I'm looking at is an edge view basically of my base as it sits on the horizontal plane, and then we have our top point here above. Now the reason I took my auxiliary off in this direction is because now I can use this length, because I know it's going to be a true length above here. So I just take the distance that I know it's going to be, which is this distance here, knock it off where it intersects. I can then finish off my tetrahedron. Now remember, keep this all nice and light, all construction. Join C up to it, like so. Drop that back down. And now basically what you're looking at is this surface here as an edge view. You're looking at this surface here straight above in front of you. This surface here is directly behind this one. So now what I need to do is put it into its rotated position. And what I'm going to do to help me put it in its rotated position is use the rotated position of the surface we have already here given to us in the question. So this is going to bring C1 back to C. My point of rotation is going to be where AB is above here. So this is my point of rotation or center of rotation. Get my compass. And I am going to rotate the point C till it intersects where my line of my rotated surface here. And then I know where it is. Now I can draw a line from AB all the way up to where the two lines intersect. And now that's the new location, or the edge view basically, of the surface here. So what I have to do now is complete the rest of it above here to its rotated position. So I'll just rotate up this point as well. Like so. Get my adjustable set square. Yeah. We're drawing my tetrahedron in its rotated position. I'm going to put it in a bit darker so you can see it nice and clearly. Like so. ABC, I'm just going to call this one D here. Bring it over here, it's called D as well. Do you want to call it D1 because it's not the actual position of it, and then D here where it actually is supposed to be, and then call this, that was C1 and this is C. This is A and B. Perfect. Now what I can do is I can bring all my points of my tetrahedron in its final location back. Remember, I already have my surface A, B, C. Now again, it's important to remember that some of this is going to be construction. So just because it's put in a bit darker here because it was printed off, ensure that you indicate that what is hidden is supposed to be hidden. So what you'd be looking at is this surface here, this surface, and this line here should be a dotted line to indicate that it is hidden detail I'm just going to move it a small bit to the left so you can see that I have a dashed line in there. Now what you can do, that you have all the different points, you can bring it up and form in your elevation. Now what I'd suggest, where I kind of messed up here a small bit, what I would have done, what I should have done, is move my auxiliary view a small bit further up so that it would be nice and clear the difference between the elevation here and my auxiliary elevation that I've done up here from my auxiliary view. But it should be okay, it won't overlap, but at the same time you just have to be careful of keeping them nice and separated so it's clear to see what is from the different views. I'm going to bring up A and B first, the easiest ones to locate because it's going to be sitting on the horizontal plane, so it's going to be on the XY line. Now I'm going to take up my points C and D. C straight up, D straight up. Take my distances from over here. That's D and this is C. Now imagine you're standing here, you're looking in this direction, so what will you be able to see? So I'll definitely be able to see my line from A to B resting on the horizontal plane, so I'll put that nice and heavy here. So where's A, that's A, and that's B over here. I'll also see my surface ADB, so A D B like so. I'll also see my line traveling from D back to C. C down to A. And now there's an additional line that's going to be traveling from C down to B, but it's going to be behind us or behind the object itself. So that's going to be dash section like so. And that's your completed elevation plan as well as auxiliary elevation.